in this video, we want to be able to say that I can define appropriate quantities for descriptive modeling. So what we are going to want to do with this is we first need to understand this word, which is metric. Okay? A metric is a rule for assigning a number to some characteristic or attribute. So let me just write that down so that we have it written. So a metric is a rule for assigning a number to some characteristic or attribute. One way we think about metric is with teachers. Teachers have a grading scale. The way that they grade you is a metric. The fact that you get a letter grade, an A, a B, a C, or a D, that is a metric right there. It's a rule, it's a guideline that is assigned a number or some sort of characteristic. We know that an A is a certain percentage. We know that a B follows a certain guideline. Okay, so a metric is a rule for assigning a number to some characteristic or attribute. So let's go ahead and look at some examples. In this example, John is applying for a home loan. His monthly expenses are $1,100 for monthly income. $1,100. His monthly income is $3,500, and his projected monthly mortgage for a new home is $1,400. Banks determine whether a person qualifies for home loan based on a metric. So based off of a scale, a standard, will depend on if they get the home loan approval. Okay, so we have at Mr. Stowell's bank, John's debt to income ratio must be 0.34 or less to qualify for the loan. Determine whether John qualifies for a home loan at Mr. Stowell's bank. Okay, so we know that it has to be 0.34 or smaller than this value. Okay, so whatever our value is, it must be either 0.34, let me write it out as it is, 0.34, or smaller than. Okay, some value smaller than that. Well, in order to do this, we need to be able to set up some sort of ratio, right? A decimal is a fraction that we've done the division on. So we need to figure out what the ratio for a debt to income is. Okay, we need to know what the debt to income ratio is. So basically what this is we are going to take his monthly spending. That's his debt. Debt to income. So we're looking at debt, and we're also looking at how much he makes. Debt to income means we are looking at the debt, look at how much he makes overall. So this would be 1,100 divided by 3,500. And go ahead and take your calculators. That is going to give us a grand total of 0.3. Let's go and round it to 2 decimals to the 100th place value. So 3,1. So does John qualify for this loan? Well, yeah. He is less than the amount for qualifying, right? It must be 0.34 or less than, a smaller than value than that. So John, we can say John qualifies. That's nice. He qualifies for the Mr. Stowell Bank. By the way, debt to income ratio, that is how much he is paying for his debt, his monthly expenses, then his income. Monthly debt versus income. We're going to do one very, very similar, worded in basically the same words. John is applying for a home loan. His monthly expenses are $1,100. His monthly income is $3,500. And his projected monthly mortgage for a new home is $1,400. That's exactly the same stuff that was in the last example. Banks determine whether a person qualifies for a home loan based off of a metric. At New Savings Bank, so a different bank, at New Savings Bank has mortgage to income ratio must be 0.38 or less. Determine whether John qualifies for a home loan at New Savings Bank. Okay, keyword, there is a difference. This one we're looking at mortgage to income ratio. The last one we were looking at debt to income ratio. Okay, difference is the debt versus mortgage. The mortgage that he's expected to pay is $1,400. The debt he was expected to pay was $1,100 in the last problem. The mortgage is $1,400. His income is $3,500. So this one is going to end up to be $1,400 divided by $3,500. That's his mortgage debt divided by his income. And that is going to give us our mortgage to income ratio. It's a fraction comparing these two numbers. And this is going to give us, dividing it out, you can take your calculators, this should give us about 0.4. And is that less than or equal to 0.38? No. So in this case, John does not qualify. So John does not qualify in this one. So keywords, make sure you understand the difference between debt to income versus mortgage to income. Both of them are ratios, but you may pick different numbers based off of that. Here's another example. In basketball, the effective field goal percent, EFG percent, is a metric to rank players' shooting availability. The metric is EFG percent equals to A plus 1.5 times B divided by FGA, where A is a number of 2-point baskets made, B is a number of 3-point baskets made, and FGA is a number of field goals attempts. The number of attempts to be scored. That is what FGA is standing for. LeBron James of the Cleveland, this place, he made 650 of the 2-pointers, 87 of the 3-pointers, and he shot a total of 1,416 attempts during the 2015-2016 season. Find the EFG percent. All we had to do with this, just substitute the values to find the metric. So the EFG is going to end up to be, well, A, remember, A is 2-pointers. We're told how many 2-pointers he made. He made 650. We're using our substitution property. This would be plus, 1.5 is the constant. The B is number of 3-pointers. We know he made 87 3-pointers, so 1.5 times 87. And this is being divided by EFG. Remember, EFG is our, FGA, the field goal attempts, is a total number of attempts. So this would be 1,416. Okay, we're just taking those values and substituting them in. FGA, number of field goal attempts. We're just taking each of those values, figuring out what they actually are, and replacing those values. From here, it's just order of operations. We do the multiplication before we do anything else. So we go 1.5 and times that to 87. So this would give us 650 plus 130.5 divided by 1416. The numerator is separate from the denominator, so let's go ahead and take that and add them together. So we go 165 plus 130.5, which is going to give us 780.5 divided by 1,416. And this is going to give us approximately 0.55, let's say 1, as our EFG percent, the field goal percentage. And that would be the answer to this one. Okay, so main thing, we had to figure out what each of those variables mean. What do they mean? Then all we had to do is just substitute it, put it in place of those values, and just use order of operations like we've learned in other videos. Let's look at this one. We're going to change it up just a little bit. How do we know where to round and when to round? So David has $27 he wants to spend on downloading music from the internet. Each download costs him $1.25. When typing 27 divided by $1.25 into his calculator, the number appears to be 21.6. Where should David round? Well, let's think about the context. He's dealing with money. Because he's dealing with money, this would be technically $21.60. So he really should have 2 decimals. However, be careful. Let's make sure we really understand what's happening. We want to know, this would be if it was dollars. This 27 is our dollar amount. We have $27, and this 1.25 is also a dollar amount. So if we divide dollar by dollar, are we still in dollars? No, we're not in dollars anymore. So that actually would not make sense. So let's go back and think about what's going on. So we no longer have the dollars. This would be 21.6. What is he trying to download? Well, he's trying to download specific songs, right? And we cannot buy a decimal version of a song. We wouldn't be able to buy a decimal version of a song. We would not be able to buy 21.6 pieces of music. We can only buy a natural number amount of music. So this one would actually be, we would want to round to be just 21. Because if he buys 21 songs, he's going to spend less than $27. In fact, if he buys 21 songs, what that's going to end up to be, take 21 times that by $1.25, that's going to give us a total of $26.25 if he downloads 21 songs. If he downloaded 22 songs, so let's say we went and took it a step farther and did 22 songs, this is going to end up to be too much. So if he downloads 22 songs, times that by the $1.25 each, that's going to give us a grand total of $27.50 in that case. So he would not be able to buy 22 songs. He would only be able to buy 21. So the place he should round is to make it a natural number. Make it a whole number. Make it a number that does not have a decimal in this case, because we cannot buy a portion of a song. Whenever you go to download music, even though we don't necessarily download music much anymore, we have the streaming services. If you were to download music, we buy the whole song. We don't buy maybe the first 10 minutes or the first 10 seconds or the first 30 seconds of the song. We buy the whole entire song instead of just a portion of it. So he would only be able to buy 21 of the songs. So we had to think within the context. Let's look at this one. Nathan wants to share a pizza equally among himself and 2 friends. He cuts the pizza into 8 equal pieces and gives each person 2 pieces. When he types 8 divided by 3 into his calculator, he gets 2.6, repeating on forever. Where should he round? Well, let's think about this. If each person gets 2 slices, so 2 slices for 3 people, so we have 2 slices, he have 2 slices, we have 2 slices, 2 slices, 2 slices, 2 slices. So we end up with, we have 8 equal pieces. We want to divide that by 3 people. Basically what this is going to end up with, he has given away 6 pieces. he has 2 pieces left, right? I know in reality, you guys would just go and take whatever pizza you have. But if we want to think about how to make it equal, make it fair for everyone, then we need to think about how would we want to round this? How would we want to take these pizzas and divide it equally among everyone else? So what we're going to end up doing is, if we look at this, each person got 2 pieces, right? If each person got 2 pieces, we have 0.666 going on forever, right? Because we have that going on forever, isn't that just 2/3? 2/3 is the same thing as 0.6 repeating on forever. So shouldn't everyone get 2 slices and 2/3 of another slice? So it's not really any rounding in this one. It's more of an idea of, let's turn it into the fraction. Turn it into the actual amount. Take the pizza, cut it into 2/3, cut the next one. You can cut the next one into 2/3 as well, and then everyone will get an equal share in that amount. So this one we would say, okay, well, each person gets 2 2/3 slices. That's it. We wouldn't necessarily want the decimal. We're told in this one, Eva is decorating a beach ball by covering it with wrapping paper. The radius of the ball is 0.25 feet. And the minimum amount of wrapping paper she will need is equal to the surface area of the ball, or 4 times pi times radius squared. That's how you find surface areas, by the way. Where r is the radius, she finds the surface area to be this amount, square feet. Where should Eva round? Okay, to be the most accurate, of course, we would not want to round anything. But for the sake of this question, we look at what she started with. Okay, a lot of the times we want to round to the same amount of decimals that we started with. So in this case, we have 2 decimals. So we want to round this to 2 decimals. So this would be 0.79. Okay, a lot of times we just round to the same number of decimals we started with at the beginning of this question.